All right, we're live again. CNBT 1311, finishing off chapter 4, floor systems, with video 4. All right, span rating on panel subfloor 3216, 3616, span in inches is 16. These are span ratings. Okay, the span rating is a part of the grade stamp found on the back of each panel. The first number indicates the maximum rafter spacing for roof sheathing, for roofs, and the second number indicates the maximum joist spacing for subflooring. So since people aren't standing on the roof all the time, they'll let you go a bigger span for the roof than they will if this was a floor in like a second or third floor of a wood frame structure for people. All right, now, okay, your mileage may vary. So you look at the rating on the subflooring. The best subflooring, in my opinion, today is plywood from APA, American Plywood Association. I hate OSB. I absolutely detest it as a building material. That stuff gets wet, it blows up, it comes apart quicker than plywood, but everybody likes to use it because it's cheap. Um, it's not near as structurally strong as plywood. There's no way OSB will ever be as strong as plywood. Period. Um, well, enough of that. Um, if you can afford the plywood, use plywood. Of course, everything's expensive now. Um, but underlayment provides your impact load resistance and a smooth surface for direct application of non-structural flooring. To me, all flooring should be structural. Okay. Um, Now, let's look at some terms that he throws out. Panel subfloor and underlayment. You heard me say earlier, you want to stagger the end joints. Make this into a quilt or a carpet. Uh, you want blocking under any edges that, and that again goes back to your code. Okay. Um, Nail it 6 inches on center along the edges. That keeps it from curling. What else does he say? Uh, why he even puts underpinning? Let's see, provide blocking under edges. Use tongue and groove panel edges not required if underlayment joints are offset from subfloor joints. All right. Underlayment is going to be what goes on the structural subfloor. Like if this is plywood and you glued and screwed this down or glued and nailed it down, then the underlayment is what goes underneath on top of this before you put your tongue and groove composite wood floor up here or carpet or whatever. Now the underlayment may be a floor leveling compound. That stuff's super expensive, and it adds weight. So again, go back. If I'm using something that can be used as a structural element and can tie it to my framework, I am going to do that. I'm going to design it like that, even though it may cost a little extra to glue and screw this thing down. Now he now finally gets around to talking about gluing. Combine subfloor to the and underlayment panels to the floor joist. Enables the panels to act together with joists to form integral T-beam units. You're building a wooden box, a diaphragm. Um, um, okay. I define underlayment as a non-structural um, element, um, like the padding for carpet or the vapor barrier for a floating tongue and groove manufactured thin wood floor. But anyway, you need to consult the American Plywood Association for detailed recommendations. Now, APA makes a superstructural thick plywood tongue and groove. It's not just 4 by 8 foot sheets, but it's tongue and grooved on the sides, and it's made for structural diaphragming, for wood framing. Enough of that. All right. He's not really telling you. I don't want you to be confused. Underlayment. Here he goes. Here he goes. I knew it was in here. All right. Provides impact load resistant and a smooth surface for the direct application of non-structural flooring. All right. So your underlayment would be a thin sheet of C or C plugged plywood or some other board. It could be a hardy board. If you're going to do a tile floor in a bathroom, you'd come in and put shower liner, the rubber shower liner over your plywood, your structural floor, and then come in with a water board on top of it, and then that's where the mastic would go for the tile. Okay, so the underlayment is non-structural, like I said before. All right. Span rating, subflooring is structural. Okay, I don't beat this up enough. And as you know, if you glue and screw it all together, it's going to act as one big giant structural member, right? So now at the end of this, we're going to throw in prefabricated joist and trusses. I've talked about this. Remember the apartment complex near my house I was telling you about, where they're using these box wooden trusses? Now look how thick they are on the ends. That's because of what? That's where the greatest load's going to go for the shear, right? These are prefabricated steel plates. They're generally rolled onto these things, pressured into them. They got big long teeth in them, so this has metal tooth plate connectors. I just said that. This is a built up cheap wooden beam. There's plywood in here, and then you take a dado bit on a table saw or a Foley bell saw, and composite that together, glue and screw it together, and they call this an eye joist, a wooden eye joist, and they're manufactured with sawn or laminated veneer lumber flanges. I've drawn this up before. Some of them have plywood or OSB web. The apartment complex is using OSB for these, same ones that are doing this. As long as you can keep the OSB contained and dry, it'll be fine. But if it gets wet for any length of time, it's going to blow up like a grenade, whereas plywood will not. All right, here's some rule of thumb for your depths and spans. Again, your mileage is going to vary. You need to consult the manufacturer, and your structural engineer needs to be involved in this conversation, or you're going to have some major heartburn. All right, here's a wooden truss with steel web members. All right, these would be light gauge, most likely cold rolled, cold formed, like the lightweight joist, instead of wood. The top cards and the bottom cards are wood. All right, with steel web members, and they're still the connectors. Okay. All right, and then wood cards with tubing. This would be like conduit. I mean, it's like metal tubing, thin wall metal tubing, EMT. That's squished on the ends, and they come in, they're pinned. You don't see too many of these floating around. And here is two 2x6 cards with a 2-inch OD steel webs, and this is a pre-engineered truss joist, and there's a rule of thumb for the depth and the span. Again, your mileage is going to vary. You need to check with the manufacturer, because these pin connections from steel to wood in these things is problematic if they're not done properly and inspection and quality control is not maintained. What you do see a lot is the glue lamb beams. All right, prefabricated joist and trusses. Here's some details of how you put them together. It's no different than a regular wood joist or wood framed structure. Now, the only difference is you might get by with a longer span, but the spacing of these things is still going to be depending on your wood subflooring, what your subfloor is going to be. Again, you go back to the designation for your plywood. What's your subfloor? Okay, is it structural 1 grade? You're going 20 inches, 16 inches, 24 inches for floor loading. I'm not talking about roof loading. I'm talking about floor loading. Okay, and so here's some details. Your code requirements will also dictate if you're using some of this stuff. So you got to check your building codes. And if you're working out on the Gulf Coast with hurricane loading, you'll have some additional metal clips. But again, it goes back. It's no different than if you're doing conventional wood framing. It's just this is lighter, and because it's lighter, you also have the propensity for it to be a little more springy. So you got to watch your deflection, and this shows it's no different than a regular steel truss. You got top cord bearing, okay, on the exterior, just like we showed the steel clips going into the wall that you could weld or bolt. This is wood, so you would attach it with a nailer. Interior detail, bracing is going to be necessary in the down the longitudinal run of these things. Why? Just like this regular joist, they're going to want to roll on you. Okay, as this stuff gets loaded, as the load increases, okay, the propensity when this bends, it's going to want to roll. It's going to want to rotate around its centroid, its axis in here. Okay, all right, it'll want to rotate around that. Now, and as you combine wind loading with it, okay, with the load up here, then the rolling gets exacerbated. So we put cross bracing in here to tie these together. So as this tries to roll, this is pushing up on that top card, and vice versa. Okay. All right. Bottom card bearing. This would be like that box truss, where you're just setting it on top of the wall, the wood stud or masonry bearing wall. How's he doing his end cap? He's got a continuous band. He really needs one down here. I don't care what anybody says. There needs to be another one. Now, let me get the pin out. Oh, God. My back is killing me. Sitting in this chair making these videos is killing my back. All right, we want another one down here. You'll have plenty of scabs and scrap around to do this end blocking. If you don't, you run the risk of when you put your exterior siding not having anything to nail to and you're just end nailing on this. It's better to have a larger surface, and it'll transmit more load. He does it. He uses two over here on an overhang. Okay, you don't have a choice on the overhang, but he's relying on this bridging down here. But if I was running the framing crew, I'd put scabs in here, just like that, just to be safe. Now, in some residential building, your first floor will be masonry, so this will be brick, and then you'll bring your siding down. And if it's done right, this is all inset and this is overhang. But sometimes I've seen it where it's not, and they have a bad design right here. This is called a water trap, and you need to Z-strip this with Z flashing, and I don't care how good you get. If this stuff is not deep enough, that flashing doesn't go down deep enough, it's one piece, and you get high blowing winds, you're going to have water blown into your building. Water will blow. It'll mitigate. What the heck is going on? Water will mitigate, will be wind-blown water into your building structure. And you got a potential lawsuit on your hands for a bad design. Don't do that. Don't do that. That's bad. It's very bad. Very, very bad. You need to keep your wall membrane contiguous, just like this. So if you need masonry on the outside, then you need to inset the masonry, bring the top wall skin down over the masonry, and it's easier to seal off, and then continue the masonry on down to the lower floor foundation. So enough of that. This is bottom card bearing with an overhang. Solid sawn lumber. In this section of wood beam, the following should be considered. Lumber species, oh yeah, structural grade, and the modulus of elasticity. Oh, come on. You do not need to worry about the modulus of elasticity or allowing bending and shear stress values. That's your engineer's job. You as an architectural designer are not going to do those calculations. And the minimum deflection permitted. And I will bet you're going to find that in the IBC. They'll have some requirements. The local building codes will, I know. And the type of connections used. So it says see bibliography for sources of more detailed span and load tables. You can drive yourself nuts and go search the internet if you want. There's manufacturers that make wooden box beams. They can be out of regular plywood or OBS. You made by gluing two or more. I've built these myself on job sites where we needed to span and didn't have time to wait for the manufacturer to get us to them. So we built them ourselves. Here's some more rule of thumbs for the depth of a wood beam. Your mileage is going to vary. You consult your engineer or the American Timber Institute engineering manual, the wood timber manual. And that again depends on the lumber species, the water content, how it was graded, how it was kiln dried, blah, 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 blah. Built up beams are just beams glued and screwed or nailed together. Glue-lam timber. Glue-lam timber is just that. It's pressure treated. Pressure adhesed. They're stacked together with glue. They're engineered to span various distances. Check the manufacturer's recommendations, and their span to depth ratios. And once these things there's glue in between here that are applied by a machine, and then they're put in a press, and it's pressed together while the glue sets. And this is not your just normal wood glue. This is an engineered adhesive, and they can be joined by finger joints or scarf joints. But then again, that's beyond where we are right now. Parallel strand lumber. PSL is a structural lumber product made by bonding long, narrow wood strands together under heat and pressure using waterproof adhesive. Parallel strand lumber is a proprietary product marketed under the trademark of Parallel. Now, that was when this book was published. This company has traded hands several times, and some of it was marketed under Packlewood, gun grips, knife handles, cooking utensils, all of the various forms of pressure-treated, very thin pressure-treated wood products were made from this. Here's another one, laminated veneer timber, which is similar to parallel strand lumber. It's a structural lumber product made by bonding layers of wood veneers together under heat and pressure using a waterproof adhesive. Having the grain of all veneers run in the same longitudinal direction, it results in a product that's strong when edge loaded as a beam or face loaded as a plank. Okay, that means it's edge loaded. That means it's loaded like this. Okay, or face loading would be coming out like this. Because your strands are running in the same direction. All right, wood beam supports. Oh my gosh. What do you guess would be the supports? You've already talked about walls, right? Bearing walls, pockets, soffits, gusset boxes, bearing plates, optional prefabricated beam seats, corbels, reinforced concrete walls, reinforced masonry walls, engineered masonry walls. There are so many different types of clips, angles, bolts, J-bolts. In this case, if this is cast in place concrete, then you'd have an embedded J-bolt coming down here. Or Sika, they come in here and drill a hole in here and then epoxy in a threaded rod down in the concrete with a Sika-based, a Sika product of epoxy. And or expansion anchors. Expansion anchors are a bad idea. It depends on what you hit with the rock bit as you're drilling down through the concrete. Beam hangers, we've talked about that. Strong ties, straps across the top. That would be like for a girder support. And again, your building code may require you to do this, especially down along the Gulf Coast, or maybe in Tornado Alley, or in seismic areas. Clip angles. This is a clip angle. Well, this is a saddle clip. This is a moderate to heavy load. This will carry more load than your normal strong tie nail into the side of the board, because this is saddle clip. These are usually heavier gauge material, and this dimension is for this type of beam. So if this is a 4x6, then this would be 4 inches across. This is manufactured. It's all manufactured as one piece, and it's a lot stronger than the normal strong tie that you would nail into the side and then use a joist hanger. But it is a joist hanger. It's just, they call it a girder support because it heavier duty, carries more load. Okay, all these are girder supports. All right. this theoretically will not carry as much because this whole clip is in just shear. This has a saddle strap across the top, and it's bearing down on the support beam for the side girder coming in. This is a repeat. We've seen this before. We have positive bending. That means it's going down. We have negative bending. Means it's being pushed up. And we go back to positive bending. Now this is a continuous beam, and we saw this in a previous chapter of a 3 support beam, right? And if you cantilever it out here and cantilever it out here, there would be less bending in here, right? Because the cantilevers would offset all of this. But we're just going to talk about splicing, okay? With steel splice plate, a mortar splice plate, Bulldog plates. I don't even think he shows a Bulldog. That's an old brand. But anyway, all right. So theoretically, if you're going to take a sharp board, you're going to make this long glue lam beam or whatever. You're going to have to splice it together, or this. You need to find your inflection points, and this is one point here. So that's where you'd start a splice plate and a splice plate, which means that you've got to be real careful with your engineering. And that would be really nice if this was uniformly loaded. But we got live load too, right? So dead load's one thing. Live load, well, you may have 1,000 pounds a square foot one day over here, and it may move over here as a live load, and then it may move over here, and then it may move back over here. So guess what happens? It's not uniformly loaded, so these points are going to change. They're going to move back and forth, and okay, fine. I think you get the message that, yeah, in a perfect world, this kind of stuff can work, but I wouldn't be staking my reputation and my life savings on this, okay? I wouldn't. Now, I have done this as a contractor back when I was a student. I ran a construction crew on a commercial site, and we had to do this for the outside ledger board, but it wasn't carrying floor loading. So the load was constant. It would not change. We had steel columns that came down, and then we had these mounting plates that were welded to the column. And then we had to bolt these heavy cedar, oh man, they were like 4x18s or something. They were huge. The architect was going crazy with this. And the siding of the building would come down behind it. And thus, these were to carry an overhang truss. So people could walk around the shopping center and not get rained on. All right, fine, okay. And there would be a column out here to catch that. So once all this was put up, no one's going to be running around on this roof, so it's all dead load. So we knew where it was at, okay. The problem was the spacing of these columns didn't match the length of the heavy cedar timber that they got from Oregon or wherever they got it from, someplace out west. So we had to splice these. We had to come up with a splice. So I came up with a similar splice like that, but I had a routed in angle iron on the backside that went down, something like that. I took my router and routed out the top so it would set, nobody could see it, and then we bolted the two pieces together and then bolted that on to the bolt plate, and it worked out well. There was no extra deflection, and again, we weren't having to worry about the inflection points, and that was a thing I brought up to the architect and engineer at the time. I think I was a senior, about to graduate or something like that at A&M. So they liked the idea. They thought it was really cool, and so we didn't have to worry about these points moving because this was all dead load. But again, like I said, be careful about this, because if it's an interior floor beam, now live loads move all up and down. These inflection points are going to change, and it could get you in trouble. Could get you in bad trouble. Where are we at? No, we're at 30 minutes. We're fine. Wood post beam connections. Boy, doesn't this look like some test questions? Especially in light of that monsters thing I put together for exam 1. Y'all are probably going to want to tie me to the stake and burn me over that. That thing was long. Oh my God. And I tried to boil some stuff out. We'll see. We'll get through this. Trust me. These are just typical connections. Your mileage is going to vary. There's all kinds of connections out there. You know, this is not a real good load-bearing connection. I mean, it'll work, but I mean, look at tiny little column, big old beam. You're trying to hold all that together with that. That's probably a better connection right there. But who knows? You and your engineer are going to have to discuss this. Again, again, your imagination and how you and your engineer work this out. Bearing blocks on these beams. Here's clips. These would be prefabricated at a fabrication shop and then brought out and set them up. These would be like a pocket thing, and you strap across. I always thought this detail was funny. Shear plates and pins. You're dealing with wood. I wouldn't worry too much about this. But these are called continuous post, continuous beam. In other words, the post is continuous up through the connection. It's a continuous post. It's up through the connection between the two beams. This is a continuous beam, although I don't know how this beam is continuous, except, watch the detail, this post begins a new post. This post is not that post. This beam comes all the way across the top. That's one piece. That's why it's called a continuous beam. Just trust me. And then we scab this other post on top of it. Why you would do that, I have no idea. That makes me nervous as an engineer. But it's called a continuous beam because the beam is continuous, okay? All right. This is a spliced post. So you've got two verticals and then you've got a space in between. To do this properly, you would this void would be full all the way down with this blocking. I would continue the blocking all the way down. You're going to need other blocking depending on how long this is. So maybe the blocking is continuous, but it's called a splice post because the post that you're making up, the composite post, is spliced and the beam is continuous. So the beam is continuous through here and the post is spliced up through there. Not a bad detail. It's not a bad way of doing something if that's what you're going to do. If it's an exterior deal, I'd certainly make that all treated, everything treated. It's a canceled connection. Stay away from this. This is expensive. You have to go in here and you have to pocket cut out the column, like with a mortise bit, and that's really cabinet shop work. That's not going to be done in the field. And just stay away from the concealed connection thing. I mean, it's all cool because it looks magic because the stuff's just up there and it's not moving, but it's extremely expensive, and getting the skilled labor to do this is not easy. Okay, this beam is continuous, and the idea is to make it look like it's all one, as if it was monolithically poured concrete, but it's wood. So you're dealing with wood, so stay with the medium and what the medium requires for connection. But I would stay away from the sealed connection. Okay, interlocking connection. This is kind of interesting. This is, depending upon what this centerpiece is, this is a very weak connection. You have your column down here, okay, and let's assume that it's three continuous pieces. All right, so it's made up column. Then you're carrying the center spline up through here. So now any transverse shear coming across here is only being taken up by this thin member as opposed to this whole thick column. Now I have seen something very similar to this, but this is a steel plate. They use a steel plate. This is structural steel that goes down a certain level, and it's bolted across through the column, sandwiches into the bolted plate. Underneath the bolted plate is more wood, and the plate goes up through the top for the architectural deal, and then it's bolted through. Obviously, that was designed by an engineer, and it can be done. Okay, it's just you got to watch your weak link in here. Okay. All right. Wood plank and beam framing. All right, we've talked about this before. Whether these are concrete or masonry walls or timber, steel, or concrete columns, it really doesn't matter. We've got our joist coming across here, right? We have structural floor plane of wood decking up here. Okay, other options are plywood, stressed skin panels. The simplest thing is to use structural plywood and glue and screw it down there. You've got a diaphragm. Could be steel girders. If it's trusses, then you'd through bolt through here. Or you'd put a wood nailer on top of the truss, on the top of the cord of the truss. Here's the top of the cord of the truss. You'd have a dimensional wood nailer up here on top, and you would through bolt this, and then lay your floor across the top. Use a carriage bolt, flat or recess the head of the bolt, and then run the floor across the top. All right, primary beam, again, this is a repeat. You've seen this before. Secondary beams may be necessary. Well, they are necessary in this particular detail. So this is a primary, that's a primary, that's a primary. Your secondary girders. And then you're going to lay your decking across here, or your flooring. And we talked about openings. There's no reason to beat that up. We've seen this detail before, basically. Depending on what kind of floor layment. Now this talks about stress skin panel. These are generally prefabricated at a factory. You can do them on site, but they're very labor intensive. And you'll notice that there's no fire blocking in here. There's no extra blocking shown. Your code may require that. There's advantages to it. You can read about it here on a stressed skin panel. Okay, combined subfloor with the underlayment, and here's tongue and groove, regular, conventional, dimensional, heavy wood decking. And this is a heavy floor. Oh my God, this is going to be freaking heavy, heavy, heavy. If this is wood flooring, a typical like wood floor on top of this, it's not floated. This is going to be a heavy structure. All right. Rule of thumb for estimating the depth of decking is your span over 30. Another rule of thumb. You want to limit the deflection of 1 over 1/20th of your decking span. This is tongue and groove wood decking. Your mileage is going to vary. If it's 2 inches, nominal 2 inch, it can span up to that. I'd be careful about that span. You check with the manufacturer. 3-inch decking can span in between here, depending on the floor loading. The problem with the tongue and groove decking is actually getting material that's dimensionally stable and getting it uniform. You know, I get a 4x8 foot sheet of structural plywood that's 1 inch thick. It's tongue and grooved, and I can lay that 4x8 foot sheet out, and it'll cover a lot of sins about the misalignment of floor joist. These things want to puck and pucker, and as the structure ages, these things will tend to cup as they dry out, and you'll have an uneven floor. And you may have to actually come in and sand it down with a floor sander, and that's a mess. Or try to cover it up with your underlayment. Not a good idea. Simple span is just that. The span goes straight to a joist and straight to a joist. Double span is just that. It goes from there to there, so it's doubly spanned. Continuous span are planks are spanned continuously over 4 more supports. Okay, so 4 more. Double is 2, so actually it's connected on the end, so you got 2 spans. Okay, and then you just got 1 span, and then here you got multiple spans. But it takes long, and these things are not that long. Okay, again, this kind of decking is used to be really popular in the ancient days of yore. My 50-year-old house has this kind of floor decking up on the 2nd floor, and it's uneven. You know, we've got ups and downs and cups and sags on some of this stuff as the wood aged, and these things tend to pull apart at times as it shrinks over the years. Okay, here's a roll of span for your decking. We've already done that, span ranges. Okay, we're at wall systems now. That's 5. So we'll pick up chapter 5 after this. He's not wrong here. The layout must be carefully controlled. And the use of random links reduces waste. It does. This kind of subdecking or flooring is expensive, especially in today's market. It's labor intensive, it's expensive, and again, getting a uniform product is iffy at times. Okay? Yeah. This is, I would stay away from that kind of floor subdecking, especially in today's market. Plywood or some engineered panels. They've got some engineering decking panels that are made out of composite materials that might work too for you, and they're light. But it's hard. It's hard to get away from good structural plywood that's laid down as a quilt, as a diaphragm. You can do a lot with that. Put in a light sub layer, underlayment, and then if you want to change the floor covering and you need to pull the underlayment, you can do that, and your client will thank you. All right, that's it. Okay, this is the end of chapter 4.